the big problem with the Fermi Paradox is that we really don't know what all of the rules of life are in the universe. We're in some ways an infant civilization, unsure if we'll even be around in 500 years, much less tens of thousands of years, where we might become an easily detectable civilization to the rest of the galaxy, perhaps millions of years to be detectable outside it. This has led to the deep question of what the solution to the Fermi Paradox actually is. On one end of the spectrum, we are simply alone right now and can't detect anyone else that might be out there. They don't exist at the same time as us, or aren't close enough for us to see. Yet on the other end of the spectrum, they might be everywhere, and we cannot or are not allowed to see them. It's anyone's guess, and that leads us to something my guest has been studying for decades: the many possible solutions to the Fermi Paradox.
You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. Stephen Webb. Dr. Webb is the author of numerous popular science books, including Measuring the Universe, The Cosmological Distance Ladder, as well as If the Universe is Teeming with Aliens, Where is Everybody? 75 Solutions to the Fermi Paradox and the Problem of Extraterrestrial Life. Dr. Webb earned his PhD in Theoretical Particle Physics at the University of Manchester. His many interests include 50s sci-fi, football, cosmology, and astrobiology.
Stephen Webb, welcome to the program.
John, it's a pleasure to be here. Thank you for inviting me.
Now, Stephen, you wrote one of the a book that's very close to my own heart because I've been intensely interested in the Fermi Paradox for decades. And in this book, If the Universe is Teeming with Aliens, Where is Everybody? 75 Solutions to the Fermi Paradox and the Problem of Extraterrestrial Life. Now, 75 solutions to the Fermi Paradox. That's amazing. Since this edition of the book, which I believe is 2015, have you come up with any more?
It's not me that's come up with them. It's the community. One of the fascinating aspects I find of the Fermi Paradox is that it is so productive. It brings in so many different aspects of science, of even sociological thinking. So the community as a whole has come up with solutions since 2015, and it's strange that you mention it because a couple of months ago the publishers said it's been 5 years. What about a third edition? And as you know, I got into the habit as a young man of collecting these, and sure enough, since 2015 there have been other solutions proposed. So there will be, I think, a third edition, but it would be awful to call it 100 solutions. It started off with 50, then that was the first edition, then it became 75. I think everyone, including myself, would lose the will to live if I just give 100. So it'll be a slightly different approach. I think I'd like to look into the motivations, perhaps, of the people who are proposing these ideas and perhaps take a slightly more general approach. But I can walk you through some of the solutions, if you wish, that have been proposed.
Absolutely.
So let's go with gravitational waves, for example. So I wrote a book a few years ago about the incredible new observatories that are going to come online. They've started to come online. There'll be more in the next few years. We're entering a golden age of astronomy and cosmology. And one of the chapters, this is about 8 years ago, was about gravitational wave observatories. And back then I was still unsure whether we would ever actually detect gravitational waves, because physicists had been promising me that for decades. It hadn't come. It was an incredibly difficult technological challenge that the astronomers had set themselves. So I wrote that chapter back then thinking, well, maybe not. About 2 years after that book was published, LIGO and Virgo detected gravitational waves. I now have an app on my phone that alerts me to the latest gravitational wave detection when neutron stars have merged and in the distant universe and been detected. The ripples in space have been detected by Virgo or LIGO. It's incredible increase in technology in those short few years.
Indeed.
Well, people have said maybe truly advanced civilizations recognize that if you can detect electromagnetic waves, then you can detect gravitational waves. Now that seems crazy because it's incredibly difficult to detect gravitational waves, right? But there are plenty of people still alive who were born before the first radio telescope was created. So from the perspective of an advanced extraterrestrial civilization, who's perhaps thousands, millions, even a billion years in advance of us, that timescale between finding radio waves and having a radio telescope and detecting gravitational waves, it's an eye blink. It just is no time at all. So they could reasonably suspect that if you can detect radio waves, then you could detect gravitational waves. So people have said, well, maybe that's how extraterrestrials would send a signal. It's really difficult to send a signal, but one paper I read recently, I think it's still in preprint, but the idea is that an advanced civilization says, what's the unique place in the galaxy when it comes to gravitational waves? Well, that is Sagittarius A*, it's the central supermassive black hole in the galaxy. And the unique part of that object is the innermost stable circular orbit. So you get a massive object, a star, say, and you feed it with energy. So you put it in that innermost stable circular orbit, feed it with energy so it doesn't just get sucked in beyond the event horizon into the black hole. You keep it there. You can keep it there for billions of years, and it will constantly radiate gravitational waves of a particular frequency. So you don't get that chirp of gravitational wave increase in frequency as you get within spiraling neutron stars, for example. It's a constant frequency gravitational wave. If they did that, and we could relatively easily detect it with the next generation of detectors like LISA, the space-based observatory, then you'd immediately know something was up. So there's this idea of a gravitational wave beacon, and I'd certainly want to explore that, I think, in more detail in a book.
Now, it would seem to me that with a gravitational wave, that would get past some of the problems inherent with radio SETI, in that everyone would detect the gravitational wave unambiguously, correct?
Absolutely. So it's this idea of omnidirectional signaling to the entire galaxy. Absolutely. It's just one of the advantages. The disadvantage is it requires an incredible amount of energy to do that. So we're talking about civilizations that far in advance of our own. But they've had time to develop.
But millions of years, even conceivably, you know, billions of years.
Absolutely.
And you talk about that in both your book and your TED Talk, that, you know, this galaxy has had a lot of time to develop a civilization. Give us some sort of scale on that.
Well, I think that's the crux of the paradox, isn't it? So on the one hand, the galaxy is big, by which I mean it can contain a lot of stuff, a lot of planets, a lot of places where life could get going. So naively, and perhaps not even naively, you would expect by the Copernican principle, this idea that there's nothing special about Earth, you would expect lots of planets to have life, and at least some of those planets to be home to intelligence and perhaps technologically advanced civilizations. So the galaxy is big, but on the other hand, yes, the galaxy is old. We know that the universe is 13.8 billion years old, give or take. And there doesn't seem to be a fundamental reason why those civilizations could not be billions of years in advance of our own. And it is difficult to get a handle on how long a billion years is. But if you compress the age of the universe into 1 year, then all of the interesting stuff that's happening here on Earth takes place in the last weeks of December. And all the really, really interesting stuff, stuff involving intelligence, that takes place just before midnight, really, 31st December in the year. That's where we are right now. But those civilizations, they could be popping up in the summer months. So there seems to be plenty of time for civilizations if they follow the same technological arc as we do. And again, by that Copernican principle, if you say that there's nothing special about us and we came into being on an ordinary planet, therefore other beings could come into being on an ordinary planet, there's nothing to stop them advancing technologically in the way that we've advanced. But they just have more time to achieve incredible things. And if a billion years presumably would allow enough time for civilizations to develop a level of technology that Arthur Clarke would say was indistinguishable from magic.
In such a situation, and we have the Kardashev scale to sort of, general guide on what this might look like. So if you have a Type 3 civilization that is, we certainly see no evidence of anything like that, but we don't know necessarily what one would look like. It's usually assumed that they'd be building Dyson spheres or something, but they very well may not be. They may take some of their form. So would it be within the power of such a civilization, as Kardashev laid out with Type 3, to use gravitational waves as a form of communication like that? Would that be not a big deal for that kind of a civilization, or would it still be a problem even at that level?
For a Kardashev 3, they could so if you run the numbers, for instance, with the particular scenario that I mentioned, which is putting an object, say the size of Jupiter, in that innermost stable circular orbit of the supermassive black hole at the center of our galaxy, then the energy associated with keeping it there is large, but it's sort of on the order of the energy output associated with a stellar object over the period of its life. So it's not outlandishly large, and a K3 civilization, you might imagine, would have access to that sort of energy resource. You could ask yourself, would they use it in that way? Why, if they've got access to such large energy reserves, why would they do that? But that's a separate question. Technologically, it would be possible for them to do it. The problem with that particular scenario, having a Jupiter, say, a Jupiter-sized mass, is that something like that, or a star, would be tidally disrupted. So it couldn't actually be that sort of object. You'd need a white dwarf with sufficient structural integrity, as it were, to stand up to those gravitational tidal interactions and maintain its integrity. But a white dwarf would require incredible amounts of energy to keep it there over a long period of time. Or you say, well, can they somehow compactify Jupiter so that it becomes an incredibly dense small object? You still get the gravitational waves because it's the same mass as it's going around this innermost stable circular orbit, but how on earth would they compactify Jupiter? So either way, we're talking about civilizations that have access to energy resources and access to technology that we just don't really understand, but we can certainly imagine it, and there doesn't seem to be anything in the laws of physics that absolutely forbids it. So we're in the realms of imagining things. Whether these are ever practical or not, we can argue, and that's part of the fun of the paradox, isn't it?
Oh, of course. Now, what are some of the other options that don't involve radio or laser? What about neutrinos? Can we see any utility to communicating that way, if it's even possible?
It's another option. It's, again, in that book, I talked about neutrino astronomy, and I was again slightly. There are problems with that. Neutrinos are great in that they go almost as fast as light, and in certain circumstances, a neutrino signal gets here before light does. I'm thinking of things like supernovae, where light itself from deep within the star struggles to leave the explosion, but as soon as a neutrino is created, it's off because it doesn't interact much with matter, so it's off. The fact that neutrinos just leave the scene of the crime, as it were, is tantamount to saying it's incredibly difficult to detect them and it's incredibly difficult to modulate them for a signal. So yes, we can imagine neutrinos carrying a signal very, very quickly, and because they don't have an electric charge, they go where you would want them to. But it requires, again, a level of technology that makes you think, would civilizations go to that bother? It's difficult to modulate the signal. It's difficult to know where the signal comes from and to detect. I personally would favour gravitational waves over neutrinos, but I was wrong about gravitational waves several years ago, so I might well be wrong about that.
Now, the case can be made too, though, that, one of the earliest things that humans developed was fire, and actually proto-humans, pre-humans. Yet we still use fire, and there are probably many more fires of artificial origin burning on this planet right now than there have ever been in human history. So that it may be that radio is just so useful that even the biggest civilizations, oldest civilizations, most advanced civilizations still use it. And we look for it, but we don't see it, except maybe in one case. What's your opinion of the WOW signal?
That's interesting. It's such a... So first of all, just to step back, I think you're right to make that point. It's all... There's a modernity bias. Maybe we can discuss that later. But as a community and scientists in general, we tend to look at the new thing. That's the interesting thing to investigate, to research. So I just mentioned gravitational waves. Everyone's thinking about these things because we've just detected them. But actually, I think you're dead right. Radio is very, very easy to create. Civilizations out there, if they exist, would know that other civilizations can easily detect radio. It has its own problems in terms of, do you go omnidirectional versus beamed and all that sort of stuff. But radio is almost a lowest common denominator, I think. So absolutely we should be looking in the radio. As for the WOW, how frustrating is it that potentially we have a signal? It meets all the criteria that you might expect, but it's a one-off. And I think in the absence of anything else to verify it, you would probably be looking for some sort of mundane, everyday explanation. What that is, I don't know, but I wouldn't bet the house on that being a signal from an extraterrestrial civilization. The tantalizing, frustrating thing is, well, it could have been. How frustrating is that?
Extremely. The WOW signal is probably the one thing in astronomy that bothers me. I think about it a lot because there's just certain things. And I actually interviewed Jerry Ehman recently, who was the scientist who wrote WOW on the paper. And it's just very perplexing, but unless it repeats, we're never going to know.
Yes, yeah. That's the awful the awful thing about that sort of signal. We have to be careful that just because we don't immediately understand something, we immediately think, oh, aliens, and that's a logical leap that many people make, and they shouldn't. So it's things like, I don't know, fast radio bursts, puzzling phenomenon, but we'll get there. We'll get this understanding of it eventually. That's the interesting part of science, isn't it? Figuring out things. But the wow signal, yes, because it is that single intriguing event, it is just so tantalizing.
Now that leads us to another area of solutions, because one would be that all we ever pick up are wow signals. And if you look at the history of our planet, the signals that we produce that might be easily seen by another SETI experiment in the galaxy are things like when we radar asteroids using Arecibo and it doesn't repeat. Nor did any of our messages that we sent, the Arecibo signal, never repeated it. So it could simply be that everyone lives in a state of question mark. What was that? Was that another civilization? And yet nobody ever really does a concerted effort to contact anyone. What are some of the other solutions like that, where it's just simply ships passing in the night and missing each other?
Well, that if it turns out that describes the galaxy, I think it would be just so lonely and such a frustrating situation. It might actually turn out to be the case, because SETI is incredibly hard, isn't it? The search for extraterrestrial intelligence. If you're going to go via radio, you have to be looking at the right time. So civilizations, if they pop in and out of existence, we don't know how long our own civilization is going to last. So you need civilizations to be around at the same time, taking into account light travel distance between them. You have to point your radio telescope in the right direction, assuming that they're beaming. You have to have it tuned to the right frequency. You have to be looking at for the right sort of signal. There's a vast phase space to explore. And yes, it's entirely possible that, as you said, you have these things bipping off here and there, and only occasionally do the two things, the signal and the receiver, align. And it's, as you say, ships passing in the night. But there are other ways of disturbing the universe, if you like, in a way that can make your presence felt. So it doesn't have to be just radio. You could, if you were a civilization and you wanted, for instance, to send out your Encyclopedia Galactica, decide that actually radio isn't the best way of doing it, because who's going to pick it up? Let's send probes. So you can actually physically send self-replicating probes to deposit your Encyclopedia Galacticas, or try and colonize if that's the way you're inclined. So the Fermi Paradox is not just that we don't hear or see them out there. There's also this aspect that none of them have bothered to use any other means of contact, seemingly. And I'm thinking by probe. And again, since we're in the realm of imagination, it's easy to imagine scenarios whereby a civilization can colonize the galaxy or distribute its Encyclopedia Galactica to all planets in the galaxy on a relatively small timescale. So the paradox for me is that there's absolutely no indication, apart from perhaps things like the wow signal. There's no indication yet of life out there in the universe. But yeah, if we're just talking about radio, it's a difficult task that SETI astronomers have set themselves.
Now, in regards to self-replicating probes, idea originally by John von Neumann, these wouldn't necessarily be the easiest things to find in your solar system if there is one present. So if it's not transmitting to us, say it's only transmitting home and not in our direction, we would never even know it was there, right?
So we're getting into those sort of classes of solution that say that yes, they exist and they're here and they're perhaps monitoring us. So there's this whole idea of the zoo scenario. So absolutely, if technology is so advanced that they can send these probes, it will be advanced enough to ensure that we don't spot them if they don't want to be seen. I think, and maybe it's an opinion that's not widely shared, but I think that if a civilization was advanced enough to do that, it wouldn't have anything to fear from other civilizations. So I don't see that there's necessarily any benefit to keeping itself hidden. But if it wanted to, for whatever reason, prime directive of Star Trek and all that sort of stuff, then yes, you're right, it certainly could. And it would be difficult to observe these things. Having said that, a couple of years ago, there was all the interest over Oumuamua, and we have the second interstellar visitor,
Borisov.
Yes, it's here right now. Well, beginning to leave, isn't it? There's, and again, going back to this idea of new observatories, there's an incredible new observatory going to come online in the next year or two. It's now called the Vera Rubin telescope. Was the Large Synoptic Survey telescope.
Oh, really?
Yeah,
I hadn't heard that they. Oh, that's neat. I hadn't heard they decided to name it that. But I am so excited for that.
Yeah,
telescope.
yes, absolutely, it's great, isn't it? And yeah, just so well deserved. So the observatory is the Vera Rubin Observatory, and that is going to be an incredible instrument, and it will be capable of detecting, because of the way it's observing the universe, it will be capable of detecting a whole load of these interstellar visitors, things like Oumuamua and so on. And if you combine that with advances in sort of machine learning, so astronomy is not just increasing in the sense that it's getting these incredible observatories. Machine learning and artificial intelligence is letting us analyze these huge data sets in ways that just are impossible for humans. So it opens up another approach, I think, to SETI, and I think it's important that we broaden the approach. It's not just radio. Yes, that's probably the base case, and it's the lowest common denominator, as I said, but we don't know what civilizations out there would actually do, because they would be by definition alien. And I think it's important that we broaden it as much as possible, and we look at gravitational waves and search through the data for that. We look at the data from Vera Rubin Observatory when it comes, and look through that, and there's all of these different approaches that we could use, and I think it's important that we do use, that we don't prejudge, as it were, what a signal might look like. Can I give you another solution that's been proffered since that second edition of the book?
Absolutely.
Just to give you an idea of what it is I'm trying to get at. It seems an outlandish idea, but it's due to Clément Vidal, a Belgian astronomer and philosopher. And he says, look at millisecond pulsars, X-ray millisecond pulsars. They're rapidly spinning neutron stars that send off pulses. It turns out that they are ideal for a passive navigation system. And in fact, NASA has investigated it, and probably if we start exploring the outer reaches of the solar system, we'll have something like that on board the probes that we send out, because it means that the probes themselves can use these X-ray millisecond pulsars as a GPS, as a galactic positioning system. It turns out that they're ideal, these pulsars, for that sort of endeavor, and we don't have to then steer the probe from Earth.
So how would that, so an alien civilization might use that as a passive navigation system, but how would that be, how does that work into the paradox itself?
Well, I just want to highlight that as a way that Vidal says we should be approaching these massive data sets. So he says most scientists, I would be one of them, says X-ray navigation by pulsars. The pulsars themselves, entirely natural objects. It's just we happen to be clever enough to take advantage of them. You could go one step further and say, well, extraterrestrial civilizations, if they're out there, would be using them to navigate themselves. But Vidal says, well, you can look at this hypothesis on a scale. You could say that maybe advanced civilizations could modulate the signals and use it not just for navigation, but perhaps also for communication. You could go right to the end of the scale and say that these super advanced civilizations have actually created these millisecond pulsars for a GPS and communication system. If you go that route right at the end scale and say that these super advanced civilizations are going off creating supernovae to create these X-ray millisecond pulsars for their own purposes, under that hypothesis, you would expect certain distribution of X-ray millisecond pulsars. You'd want them beaming preferentially in the beam, in the plane of the galaxy. You would want them, if they are an artificial GPS system, they would have certain characteristics. We could search for that. I don't believe for 1 minute that these pulsars are anything but natural. But if you take the hypothesis that they could be artificial, you can then start looking at what the hypothesis would predict and then go and test it. And so what I'm saying is that we're getting these huge data sets coming through, and I think we should be open to interrogating those data sets in a variety of different ways that might seem completely off the wall and probably won't succeed, but there's no harm in trying.
No, not by any means. You have to look. As a matter of fact, I recently had a discussion with the scientist Beatrice Villarreal, she's looking for stars that seem to unnaturally disappear, where there's no known, I'm sure she's going to find all kinds of interesting natural phenomena that can make a star dim or disappear. I mean, we've already started seeing that with Tabby Star and cases like that. Mm-hmm. Yep. Well, maybe you might see one that is disappearing in a way that just isn't possible without a civilization. And it's been interesting because it just seems to me over the last 10 years, people have cooked up way more detectable technosignatures than what anyone had thought back in the days of, Cocconi and Morrison, when they said, look for radio beacons. Well, then radio beacons, omnidirectional ones, don't really make a lot of sense. But then everybody came up with a whole bunch of other ones, from looking for CFCs in an exoplanet atmosphere and all kinds of interesting stuff in recent years.
But going back to that idea of the modernity bias, it's if you go back to 19th century Gauss, one of the greatest minds in history, inevitably, he had a set of mental furniture produced by the world in which he was living, and his idea about communicating humankind's presence to Mars, in that case, would be to plant Pythagorean forests in Siberia. So you have a 3, 4, 5 triangle forest. His idea was that any Martian astronomers seeing that would immediately know that wasn't a natural phenomenon, and therefore Earth must be inhabited. That was the level of technology that was available to him, and that's how he was thinking. One of his students came up with a similar idea about digging a ditch and putting kerosene in and setting it alight. That was the technology that was available to them at the time. That's what they thought they could do. A little bit later, civilization here was almost synonymous with canalization, this idea of getting dirty water away from you and clean water to you. And as soon as that was happening in Victorian cities, people started seeing canals on Mars and coming up with romantic ideas about why that might be the case. 20th century, we invent radio, and then suddenly radio's the way to do communication across interstellar distances. 2000, everything's digital, and then people say, oh, maybe we're living in a simulation. Maybe that explains the paradox. 2015, LIGO and Virgo see gravitational waves, and then we're thinking, I'm sat here talking to you thinking maybe gravitational waves is the way to go. So the suggestions tend to follow our technological capacity at any time, and I think it's inevitable. What else can we do? But we need to be aware, I think, of that bias, and maybe just be a little bit more humble and think, let's not prejudge. Let's try and be as flexible in our thinking as possible.
Now, speaking of biases, there are others, and another one would be that a technological civilization might be producing radio, but they're just not doing it from a star system. They might be, for some reason, not located on a planet. So that brings in a location bias where we're like, well, we live on a planet, therefore they must. And there's just no reason to say that.
I mean, you're right. I mean, there's so many biases, and it's so difficult to move away from anthropocentric thinking. I would suggest that for life to get going, it requires certain things. So, for example, it's difficult to imagine life as we know it. We always have to say life as we know it. And there is, I guess, a philosophical question involved around how do we define life? How would we recognize it, perhaps, if we go out there and see something? Indeed, is it possible that there's a shadow biosphere even here on Earth? That's another question we could investigate.
Yes, that's interesting stuff. We may have a shadow biosphere that we don't really have an easy way to detect.
Yeah. I mean, if
maybe all around us.
Yeah, I mean, if the claim is that life gets going easily, one answer to the Fermi Paradox could be that actually it's an incredibly rare fluke that you get from inanimate matter to animate living material. We don't know precisely how it happens. You could say it's an incredibly rare fluke, in which case Fermi Paradox solved. But if we assume it's a natural event, and some people say it's actually very easy to get from non-life to life, then you could imagine back on Earth when our abiogenesis event took place, the event that led ultimately to us, maybe there are other events that relied on different chemicals, different coding systems. And if that's the case, if you swap one of the key elements, I mean, life as we know it depends on carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. The phosphorus actually gives rise to yet another possible answer to the problem. We maybe touch on it later. But you can imagine swapping out one of those elements for some other element. It would lead to potentially a life form that's very different to what we have. So it could be, potentially, if life gets started very, very easily, that multiple genesis events took place on Earth, and we have this shadow biosphere around us that we just don't recognize. It's possible. And again, unless we look with an open mind.
Which is hard, because
yes,
microbiology is hard. It's hard to detect.
Absolutely. None of this is easy, which again makes it fascinating.
Now, the interesting thing, I think the most interesting thing, is if we did find a shadow biosphere, it's got to be microbial, or else we'd see unrelated macrofauna walking around. But if it's microbial and say it's old as well, say its genesis happened a billion years after our type of life, came about, it brings us to one scary filter: the idea that prokaryotic and life tends to only very rarely, or perhaps uniquely, jump to eukaryotic life. And we'll get into that when we come back. We have to take a break. I'm joined today by Stephen Webb, author of 75 Solutions to the Fermi Paradox and the Problem of Extraterrestrial Life. Back in a moment.
John, you haven't told the viewers to subscribe for ages.
Like, subscribe, and share. And we're back with Dr. Stephen Webb. Now, Stephen, within this idea of a shadow biosphere, as we mentioned, it brings up one of the solutions to the Fermi Paradox, and it's the one that I admit I am most sympathetic to, that I wonder about, that it took a very, very long time for the simplest life on Earth, the prokaryotes, to make the leap to eukaryotic life, an extremely, very glaring amount of time. And if we did find a shadow biosphere, it would be microbial, and it never made that leap. So that might suggest that the solution to the Fermi Paradox is that intelligence is simply very, very, very rare, extraordinarily so. What's your view on that?
I think that if we did detect a shadow biosphere, or if we detected the remains of, even if it's fossilized remains of life on Mars, or if we go to Enceladus or one of these moons and discover an independent genesis event, it makes it incredibly likely that the galaxy is filled with planets where something similar has happened. I don't believe there's such a uniqueness about the solar system that it could happen multiple times in the solar system and never anywhere else. So yes, we would then expect lots of planets to have microbial life at least. But then yes, you ask this question: can we get from simple single-celled organisms to multicellular life, this prokaryotic, eukaryotic transition? And there's some recent work, and the reason I'm not a microbiologist is I can never pronounce the words that they use in these species, but I believe it's called Prometheoarchaeum. They've, in the past couple of weeks, they've, I believe it's Japanese researchers, have found evidence that this actually might have been the event, that Prometheoarchaeum had tentacles and it grabbed a passing bacterium, and then instead of that being food, that bacterium entered a symbiotic relationship and it actually provided useful energy to that Prometheoarchaeum. That could be an incredibly flukish event. So it's not just that event has to happen and that symbiosis takes place, but then it has to be such a useful thing that it spreads. And I think, yes, if I had to bet, I would guess that we probably are living in a galaxy where there are multiple places where abiogenesis took place, and that there's lots of microbial life, but that transition to a higher grade of life is relatively, probably very rare. And then in order to reach a stage of intelligent technological civilization, you have to have a variety of other things happen, one of which is a nice stable climate for billions of years, and there are reasons to suppose that Earth is flukish in that event. So then you start thinking about the number of different things that have got to go right in order to reach this end point. And I think for a long time people have been overawed by this large number in the problem when we discuss the Fermi Paradox, which is the number of places that life could have started. But we don't actually know whether that's a big number in this case. If it turns out that it's relatively flukish to go from prokaryotic grade of life to eukaryotic grade of life, if it's relatively difficult for that to take place on a planet that is then stable climatically over billions of years, and so on and so on, personally, I think that could resolve the paradox.
And it seems a reasonable solution because the chemistry of life is complex, of course, but it clearly is not impossible. Intelligence is a completely different thing from that. So just the chemistry part of it, even though it's complex, we're probably going to know within the next 20, 30, 40 years how that works. And we'll be able to say this is either a fluke or this is just a natural end of chemistry, of organic chemistry in a certain situation. And life, at least microbial life, will arise regularly. And again, we have two ways of finding that out. We have the scientists that are looking at the origins of life, and we also have Europa and Enceladus and all of these ice shell moons to look at that may well have something living in them. But that's exciting to me because that's a question that can be answered within my lifetime. Whereas an alien civilization, maybe not.
Yeah, it is just one of the frustrations, isn't it, of getting old, that there's all of these interesting scientific questions you want to live long enough to see the answer to. And some of them you think, they're going to nail that. And I'm sure biochemists will in my lifetime. There are others where I know I'm going to be on my deathbed just cursing that there are these things I'm not going to know. I mean, going back to an earlier question about new resolutions of the paradox, and I mentioned phosphorus earlier. I should say that chemically, life on Earth, again, it's life as we know it, but all life forms that we know about depend on carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. And that phosphorus is actually relatively rare. And we're not 100% sure about how Earth got its phosphorus. Ultimately, it would have been cooked up in a supernova, and this is very, very tentative suggestion at present, and the astronomers who made it want follow-up time to recognise whether this is actually the case or not. But it's possible that certain supernovae are required and to explode in certain ways to deliver the phosphorus into the interstellar medium that is then later transported to a planetary system. So it's possible that this is another aspect that makes chemistry or biochemistry difficult, that you need a planetary system that was formed around the right sort of supernovae. But again, these are sorts of questions that I think we will get a better handle on over the next 10, 20, 30 years.
Now, what of alternative biochemistries? Because some people have said, well, what about silicon, or variations on, I think boron is one of them too, that maybe, and there's counts against all of them, much, much more so than carbon. But do you think it's possible that, silicon-based life that isn't a machine could possibly be out there and surmount that problem of the phosphorus rarity issue?
I don't think silicon would swap with phosphorus. There's occasionally you get claims that you can swap one thing with another, and arsenic-based life was, I was going to say, all the rage a while ago. There was a suggestion made a couple of years ago that arsenic could form the basis of a life form. It turns out that actually what it was an arsenic-tolerant organism. It still required those 6 elements. And there's no, to the best of my knowledge, no life form on Earth that doesn't require those base 6 organisms. Now, it's possible, I guess, that, again, in the next 10, 20, 30 years, biochemists will start tinkering with the basic building blocks of life, and they'll get a better handle on whether these things are required or not. My guess is actually probably yes. It's anthropocentric, I know, but there are certain properties of water, for example, that I can't imagine life doing without. Carbon, it's a very, one of my teachers once called it a very slutty element. It'll go with anyone. So it's a very, it's almost unique, not quite, but it's almost unique in its properties. So it's difficult to move away from this anthropocentric thinking, but if I had to guess, I would probably put money that if we ever find life out on other planets, it'll be based on the same sort of chemistry. It might look completely different. It might be very, very different, but basic building blocks, I suspect, will be the same. It'll be a reliance on water, it'll be a reliance on carbon, and so on. You mentioned, interestingly, a silicon-based life form that's artificial. That, I think, is an interesting question. When we go out there, will we see silicon-based life that is artificial?
Yes, I made that distinction for a reason, because we will get into this later, but there may be certain scenarios where you don't want to answer the Fermi Paradox, and especially has to do with machine civilizations. However, now, in regards to the chemistry of life, I had an interesting thought. So if supernovas, only of a certain type, very special supernova, will produce all that phosphorus, we know of at least one sibling of the sun that seems to chemically have formed in the same solar nebula as our sun did. Would that be an interesting indicator to look for exoplanets with life on them close by that are also siblings of the sun because they would have the phosphorus? Could a focus be put on that?
Absolutely. I think that's a tremendous idea, that we should be looking in the local neighborhood for that sort of experiment. And again, going back to this idea of credible new observatories, we can also get a handle on that sort of question about whether phosphorus, whether Earth might be special in having phosphorus and being formed around a particular type of supernova. We have the James Webb Space Telescope coming. The launch date keeps being put back.
We've waited so long.
It will get up there, I'm sure. And it is going to be in a tremendous observatory. And it can answer those sorts of questions. So, again, it's about waiting, but we are going to get industrial amounts of data from multiple different observatories in the next few years. And a lot of these questions, I think, will be answered. The question in my mind is it going to sharpen the Fermi Paradox? And I suspect it will. All of this data.
It leads to interesting thinking. I was just, again, thinking, is that if you have a civilization that finds another civilization around a star that formed as a twin of sorts in the same solar nebula created by the same supernova, are they actually really aliens?
Well, what an interesting thought. We are, here on Earth, we are all life is interrelated. We will share, if we ever find life, we will share only prebiotic chemistry, presumably, with that civilization, unless we were seeded deliberately. I mean, that's another possibility, isn't it? That directed panspermia, that there was a unique civilization that deliberately seeded planets with life, in which case, yes, we would be connected. But assuming we just share prebiotic chemistry, I think there are ethical questions involved. Would we somehow be closer to those life forms than life forms that formed around some other supernovae elsewhere in the galaxy? An interesting question. I've never really thought about it.
One could also ask, too, that what effect does this type of star that you live around have on the evolution of your species? So if you have another civilization that evolved around a sun-like star, they might bear similarities to us as opposed to a civilization around a much darker star, say a red dwarf. And I know there are problems with red dwarfs and habitable zones, but say it's possible. Life there may look radically different, akin in some way maybe, but it would appear radically different. And you would have, I don't know, much bigger plant-like things or something like that can collect much, much more light, or light at different wavelengths that the star's producing, or maybe it evolved to use ultraviolet. Which brings us to another question. If a civilization decides, there are stars that are wholly unsuitable for life to appear around. We'll use Betelgeuse as an example because it's currently acting up. You would not expect to find any planets or anything at Betelgeuse, so therefore you're not going to point a radio telescope towards it, at least for SETI purposes. But could such a thing be more useful for an alien civilization, or a black hole for that matter? Could they be getting their energy from a black hole where we normally just wouldn't look, and that we're just missing them? Or could it be that life, I remember there was a concept of Dyson sunflowers where life can presumably exist in space itself. So this again gets into biases. Do you think that we should probably alter our strategy in SETI to look at those types of scenarios a little bit more than is being done? Because as far as I know, it's not being done.
Yes. So you mentioned that earlier, and I went off on a tangent, as I tend to do. Yes, you're right. This is another bias. I think it's likely that if we see life out there, it will have formed on planets that are relatively similar to the Earth. And the reason I mention that is again to do with water and to do with things that I think are probably a real requirement of life. Once you get to a certain level of technological advancement, and that's beyond what we currently are at, but you can imagine that in a few hundred years or a few thousand years, if we survive, which is another possible solution to the paradox, isn't it? Maybe civilizations don't. But if we survive, then yes, I think the bias against having to look at Earth-like planets going round sun-like stars, that becomes then in play, because would a civilization necessarily want to stay there if it can move? A driver might well be access to energy, ready access to lots of energy, and there are ways of doing that. For instance, creating a Dyson swarm, so they may stay in situ and use something like a Dyson swarm. But I think you're quite right. Maybe they decide to go to these hot, bright, short-lived stars, make use of the copious amounts of energy that are there, and then move on. So given that we don't know anything about what a civilization might do, I think, again, it's important to try and broaden what we search for as much as possible, just on the off chance, if nothing else, that that's what a civilization decides to do. Let's look there. Yeah.
Now, just to shift gears, what initially drew you to compile this list of solutions to the Fermi Paradox? What in your mind said, I'm interested in this, I'm going to go do it? Was there something that precipitated it?
Yes. So I was a science fiction geek as a kid. Asimov, Heinlein, Clarke, the big three. In particular, Asimov, I remember going to a public library and picking a book off the shelf. And I was so young that I mispronounced the name Asminov at the time. And I think it was probably one of Asimov's science books. And as you know, he wrote about everything. He wrote science books for kids, very, very good science books for adults. He wrote about history. He wrote about literature, the Bible, pretty much everything, and science fiction as well. And he was a big influence on, I think, the way I think. He would have celebrated his 100th birthday this month. There's 506 books on the canonical list of Asimov books. I have 503 of them. Incidentally, if any of your listeners have got history of chemistry, a chart, history of mathematics, a chart, history of biology, a chart, those are the three I'm missing, give me a call.
It's just Asimov was so unbelievably prolific in writing that I don't have them all either. So one of these days I'll compile a list of the ones that I don't have.
So yes, he was a huge influence on me, and in many ways I got an education from him. But one of the activities he was involved in was his magazine, Asimov's science fiction magazine. He lent his name to it and he wrote editorials for it. I get it still. And I first came across the Fermi Paradox in a 1984 issue of that magazine. And Stephen Gillette wrote an essay called The Fermi Paradox. And the next issue, there was a rebuttal by Robert Freitas. And there was quite a heated exchange subsequently in the letters column. And I thought, what a fascinating question. In part because you can view it from these two angles. On the one hand, of course, science fiction is telling me that we live in a galaxy that's full of life. It's teeming with life. Some of my favorite television programs, Star Trek and Doctor Who, were telling me that. My favorite films, Forbidden Planet, it was telling me that. I was living in a science fictional world. People were walking on the moon. Of course we were going to go out into the galaxy and we'd meet other civilizations. But on the other hand, there's this observation, or rather lack of observation. It certainly seems as if the galaxy is cold and dead, and you can almost flip-flop between opposing views, I think, with the Fermi Paradox. On the one hand, part of me wants to believe that we inhabit this exciting galaxy full of life, and imagine what we could learn from them. But on the other hand, there are various indications, I think, that maybe it's just us. So I just found this a fascinating question, and I learned almost by accident that people from different fields were bringing different points of view to bear on it. So physicists, of course, we always pile in with our opinion on everything, but astronomers, of course, but biologists, historians, sociologists, everyone was chipping in to this question, and I just got into the habit of collecting them.
Now, one thing you mentioned in the book, and this is something doing what I do, I get asked about constantly, is the UFO phenomena. What is your take on that? I know you have a unique take.
Well, I've seen a UFO. Again, it was one of the most formative experiences, almost, I guess you'd say, that I was out in the street, I was playing football, soccer, as you say in America. That was back when you were able to do that in a street. And I was with a friend. We looked up and we saw a beautiful silver disc hovering over the houses. We stopped and we watched it, and then it just shot away incredibly quickly. And we ran into the house to tell the grown-ups. Looking back, at the time it was a huge thing. Looking back, as a grown-up myself, I would say, well, there must have been some explanation, that my brain was imprinting a meaning on the visual that I was getting and short-circuiting various logical processes, and just seeing that light in the sky and saying it's an alien craft. I was living in that science fictional world. It was always on television. The Invaders, for instance, I probably watched that the night before. So I think my youthful brain was imprinting a meaning on photons that were entering my eye. Back when I experienced it, it was incredibly real. Now, I'm sure that when people look up in the sky and see lights, they're seeing things, right?
Oh, I agree. We have to make a distinction here. UFO is unidentified flying object. That places no identification upon it. And, of course, there are many, many things that can happen that might produce a phenomenon that one misinterprets. I have seen out on cruise ships, out in the ocean, fata morganas of lights from cities. And if one didn't know what that was, it might easily be taken as a UFO. As a matter of fact, there's one famous example of a cruise ship bridge, a fata morgana of a cruise ship bridge that some said was an alien spacecraft, which it was not. But one might see something in the atmosphere, especially if you're young, and not really understand what it actually is and misinterpret it. Is that what you feel?
That's exactly what I did. Looking back, I can still clearly visualize what I saw. I can't explain what I saw. Someone recently said perhaps it was an imprint of the football, the soccer ball that I'd been playing with. You sometimes get that after impression of something. Maybe, I don't know. It's just one of these things that you have to say, you don't know. It was unidentified. What in recent years has interested me is the way that there are cameras now around the world. We have cameras in cars, dash cams. We have cameras on bicycle helmets. We have security cameras on buildings and in houses. And they're beginning to catch really what were rare astronomical phenomena, such as meteorites and shooting stars and so on. It used to be very difficult to capture those because they happened so quickly. Now you see them relatively frequently. What none of those cameras have detected so far is a flying saucer, and I find that very telling.
I've also noticed too that there is a geographical aspect to it. The people that see UFOs tend to be they overwhelmingly tend to be Americans and Canadians, but also Europeans in the first world countries essentially. But if you talk to people that aren't familiar with the pop cultural phenomena that surrounds that, they never really see them. And that's another telling thing, I think.
Yes. And another telling thing is that the form of the observations, again, tends to track human technology and what appears in human films and entertainments. So I think it's very telling. Of course, you have these people that say they were abducted, and there's always a lot of probing going on. And clearly, if that were a true event, then yes, if you take them at their word, that resolves the Fermi Paradox, doesn't it? They're here and they're probing people, but there's absolutely no supporting evidence for any of that. So I think we have to rule that out as a solution.
I would expect so, unless in one specific case, the von Neumann probes, if one happened to dip into the atmosphere to do some sampling and someone saw it, well.
Yeah. We always have to, I think, approach these things with an open mind. But as Carl Sagan said, extraordinary claims require extraordinary evidence. So certainly things are possible, but I wouldn't accept that as evidence unless there were some supporting evidences to go along with it. Certainly possible, but I find it unconvincing.
I agree. And there's also wishful thinking. I think there are people that wish that were aliens here, but I say be careful what you wish for, because there are some very frightening solutions to the Fermi Paradox. All right, Doctor, thank you for joining us today. It's been a fantastic discussion. And when you release the next edition of the book, I hope you'll come back and visit us.
Absolutely. It's been a pleasure.
Randy's Garage. Want to let you in on a little deal. We're having a sale this week on used auto parts from an 85 LeBaron. It's a deal you can't refuse. Now, how can I help you? An engine build, you say? What are you doing, building a rocket? That makes perfect sense. Well, here's what I can do for you. I can do the whole package for $50,000. If you could just text me that delivery address. Wait a second. I know this address. I know who you live with. It's gonna cost you an extra $600. A turkey charge for association with that turkey. Yeah, that's easy for you to say. You're using his credit card. I'll have this out to you around about next Thursday.